Hello and welcome back to another video. Here we are going to solve the next three questions of October November 2020 970911, that is pure mathematics 1. The component is 1 1. We have already solved the first 5 questions in the previous video. Here's the question number 6. The equation of a curve is y is equal to 2 plus root 25 minus x square. Find the coordinates of the point, only one point we need to find, on the curve at which the gradient is 4 by 3. So gradient function will find out, and we know that if y is given, the curve is given, the gradient is going to be given by dy over dx, and we'll differentiate it. Before that, we can rewrite this curve as 2 plus 25 minus x square whole to the power 1 by 2, because square root we can write it as 1 by 2. Then the differentiation would be 0 because it is 2 plus here we are going to use the chain rule, 1 by 2 25 minus x square whole to the power 1 by 2 minus 1, that is minus 1 by 2, multiplied by the differentiation of the bracket 25 minus x square, it is going to be minus 2x. 2 got cancelled, and the gradient function is going to be minus x upon this 25 minus x square. It is minus 1 by 2, so in denominator it would become plus 1 by 2, and plus 1 by 2 we can write as the square root. It is going to be 25 minus x square. Now we need to find the point where the curve has the gradient as 4 by 3, so we'll equate it by 4 by 3. Now we can see this is negative here and it is positive, so it is and of course the square root value can never be negative, so the only possible possibility to make this as positive 4 by 3 when we take x as negative value, otherwise we cannot make it as 4 by 3. So let's solve it. We will solve by taking the square both the sides so that we can get rid of this square root. It becomes x square upon 25 minus x square is equal to, another side is 16 by 9. Let's do the cross multiplication. Then we will get 9x square is equal to 16 into 25 is 400 minus 16x square. Now let's take it to the one side. 99 plus 16 is 25. X square is equal to 400, or we can say x square is equal to 16, and hence x would be plus minus 4. Now we cannot take plus 4 because if we take it as plus 4, it would be negative 4 over 3, which is not true because we require the gradient to be 4 by 3. So we will take only x is equal to minus 4 is possible here. So we'll find the y coordinate for this. X is equal to minus 4 by putting here. So it becomes 2 plus root 25 minus 4 square, that is going to be 16. 25 minus 16 is 9, so it becomes 2 plus 3. And hence the coordinates are going to be minus 4 comma 5. We have to be very careful that we cannot take the positive 4 here, because otherwise it will give the negative 4 by 3, which is not possible because we don't require it at all. I hope it is clear. Let's do the next question. Here's the question number 7th A part. Show that sine theta over 1 minus sine theta over 1 plus sine theta is same as 2 times tan square theta. That is, it is equivalent to 2 times tan square theta. So we can see the denominator, it is 1 minus sine theta and 1 plus sine theta, and numerator it is sine theta at both the places. So we can simply take the LCM, or we can say solve the fractions. So it would be LCM would be 1 minus sine theta multiplied by 1 plus sine theta here. This, and then cross multiply sine theta multiplied by 1 plus sine theta. minus sine theta multiplied by 1 minus sine theta. So it will become, in denominator it is 1 minus like it's a minus b, a plus b, so it become a square minus b square, that is 1 minus sine square theta, and in numerator it becomes sine theta in plus sine theta into sine theta is sine square theta, minus sine theta into 1 is sine theta, and minus minus plus sine into sine is sine square theta. So these two got cancelled and we got it as 2 times sine square theta upon 1 minus sine square theta is cos square theta, the identity we have used, and hence we can write 2 times sine theta upon cos theta whole square, and that is 2 times tan square theta, and that's the right hand side. So I hope it is clear. Let's do the B part. Here is the B part. Hence solve the equation sine theta over 1 minus sine theta minus sine theta over 1 plus sine theta is equal to 8. So from the previous part we have seen that this is going to be 2 times tan square theta, and this is equal to 8 given. So we can say it is going to be tan square theta is equal to 4, or tan theta is equal to plus minus 2. So we will get theta from tangent inverse of 2, and theta is equal to tangent inverse of minus 2. So now we will calculate from calculator this angle between angle between 0 and 180. So tan inverse of 2 is 63.434, so we write 63.4 degree, and since it is negative so it would be minus 63.4 degree. So it is acceptable, but for the next angle we will always find the all possible angles for tan, and in tan we know the next angle we always find by tan 180 plus theta. So if we do 180 plus 63.4, it would be more than 180, so we will not do that. But here, since it is not acceptable, we will check for this. So the next angle theta would be 180 plus this angle minus 63.4, and this is going to be 63.4, and here it is going to be 116.6 degree. So the solution for this would be 63.4 degree and 116.6 degree only. No other angles are possible. So let's do the next question. Here is question number 8. A geometric progression has first term a, common ratio r, and the sum to infinity s. A second geometric progression has first term a, common ratio capital R, sum to infinity 2s. So the first part is a, show that r, small r is equal to 2 times capital R minus 1. So we are going to use the formula for the sum to infinity, and we know that sum to infinity for first term a and common ratio r is going to be a over 1 minus r. And from the second part, for the second geometric progression, the sum to infinity, it is given 2 times s. This would be first term, which is a over 1 minus common ratio here, capital R. And it is understood that R should not be more than or equal to 1. Otherwise, this geometric progression will be the sum to infinity would be infinity, which would not be finite. Now we can substitute the value of this s here to get the value to prove this. So s is a over 1 minus r. I am putting here, so I'll get 2 times a over 1 minus r is equal to a over 1 minus capital R. A got cancelled, and let's do the cross multiplication. it is 2 minus 2r is equal to 1 minus r. I'll take this thing this side, and another side, we will get r is equal to 1 minus 2 plus 2r, which is in fact gives us 2r minus 1. So hence we proved that r is equal to twice times capital R minus 1. So that's proved. Let's do the second part of this question. It is given that third term of first progression is equal to the second term of the second progression. So we know that for the first progression, the first term was a and common ratio was r. For the second one, it is a but common ratio was capital R. So nth term for progression, geometric progression, is always going to be a r to the power n minus 1. So here it would be the third term. Third term means a r to the power 3 minus 1, that is 2, is equal to second term of this with common ratio capital R, and first term as a would be a into r to the power 2 minus 1, that is 1. And we can cancel a, and from the previous part we know that r is equal to 2 times r, capital R, 2 times capital R minus 1. So now the question is to express s in terms of a, and we know that s is a over 1 minus r. So we r square is equal to r, and we know from here, so it would become 2 times capital R minus 1 whole square is equal to r. So it is 4r square. Let's open by the formula identity, minus 4r minus r is equal to 0. It becomes 4r square minus 5r plus 1 is equal to 0. Now since we know that 4 into 1 is 4 and 4 minus 4 minus 5, 1 is minus 5, so it become, we can directly write 4r minus 1 in one bracket, another bracket it is going to be r minus 1 is equal to 0. So from here we will get two values of r is equal to 1 or 1 by 4. 1 is not possible. Again, why? Because if it is 1, then this progression will not converge, it will be infinite, and hence now it means s is going to be a over 1 minus r, or we can say a over 1 minus 2 capital R, that is 1 by 4 minus 1. So it become a over, it is 1 by 2 and 1 minus half minus 1, that is minus 1 by 2, so it become 1 by 2 plus, and hence it becomes 2a over 3. So s in terms of a would be 2 over 3 times small a. So that's it. I hope it was of some help. Thank you so much.